boot it. So thank you for coming to my talk. I'm atsushieno, random wild Android audio app developer in Japan. And this talk is about Android audio beyond winning it. It's totally about Android audio applications. And anyone not hearing any sound from your mobile devices? No, I guess everyone hears something from mobile devices, either Android or iPhone, whatsoever. So everyone kind of appreciate audio feature, and should you care about any audio stack? So maybe yes, you're using some audio feature, which is given either by platform or some applications. Like you play some games, or you make some calls, or you're working on video calls, or you're receiving some emergency alerts or notification whatsoever. So they involve audio. And when it comes to music and audio applications, maybe raise your hand if you don't use any music application or video application like YouTube, whatsoever, or mobiles. I'm proud of you if you don't, but most of you would use that. Anyway, and we use a lot of apps like iTunes, Spotify, YouTube, TikTok, whatsoever, and they are music and audio applications, so they are still involved. But when it comes to, say, creative music applications, like anyone using your mobile for composing music or editing videos or whatsoever, maybe not a lot of you do that. But today I'm mostly talking about such kind of software, so I'm going to talk something irrelevant to you. Anyway, so in this particular category of audio applications, we are pretty much behind iOS. And it's like, say, I like to watch some news from some music app software updates or whatsoever. They have some news updates on, say, Twitter or whatsoever. And then whenever I see they have released some mobile products whatsoever, I get excited and say, let's go for that, and follow the link and find that the actual mobile product is actually iOS version and no Android version. And that happens a lot, and I get sad face. And so that should change. I want to see more Android versions of those. And particularly, where are we behind is like, we don't really have to worry about media applications. Like we have YouTube app, TikTok app, Spotify app, or even Apple Music app on Android Play Store. But what we are missing is more like creative music applications. When it comes to music creative software and instruments whatsoever, we are totally behind iOS. But why Android is such a lot behind, and it's not even a first citizen in this region? Commonly said claim is that Android audio is laggy. And it was like, say, if you tap something and hear something from device, it could be like 100 milliseconds behind, like that. It used to be like that bad, but this is a graph from 4 years ago from Google, and there was a Google audio app developer advocate, and he posted something saying that the audio latency had become much smaller than before. And it was like, it says like, say, the worst case is like 40 milliseconds late. I mean, it's kind of, it's still good. And it could be like, it should be like 30 milliseconds-ish in the average ones. And then it's not very ideal, but it's fairly good. And this is a graph from Chromium website, and it's very small, so I would read it. But most of those numbers are like, those round-trip audio latency is like less than 20 milliseconds. So it's very good. And I didn't really explain what audio latency is, by the way, and so let me explain that. Basically, whenever we deal with audio, any audio program should be real-time safe. It's a very special kind of coding. Like, you can write very inefficient code, but as long as you keep deadline, it's totally fine. That if you have very high-performing code that sometimes misses some deadline, I mean, it doesn't finish the audio processing within certain time, it's no-go. Real-time programming is such a special kind of coding. But we usually need this audio programming stuff only within audio threads. So we have some tailored high-priority audio threads, real-time audio threads that is only used for audio processing. So if you have GUI on the audio application, it's totally fine to miss the deadline in that thread. We don't really worry about real-time safety there. And if you miss any deadline in audio thread, what happens there is like we get either some kind of delayed sound or worse, it results in audio glitches. It's like kind of noises. And sometimes your audio application is connected to, say, loudspeaker. And like I'm connected to this speaker. And sometimes it misses the deadline and then it results in noises and it could become like bang, and then the speaker could get broken even. So this is very problematic. We cannot really miss a deadline. And when pro musicians are using some audio applications, sometimes if you miss some deadline that get delayed, they would start feeling annoyed, and then also they don't want to retake a lot of recordings either way. But I'd say Android is kind of done in this latency stuff. Android platform team is kind of done with this kind of work. When they finished the A-audio work, which is a new API starting Android 8. I'm saying 8 is new. and when they also defined some requirements on Android CDD, compatibility design definitions, and they have some sections about audio latency and especially professional audio latency. And when they define it, it's like the pro audio devices must finish everything. Round trip latency latency y should be within 20 milliseconds. So if you get any pro audio ready devices, you're totally fine, almost fine with latencycy And the pro audio compatibility devices are like, say, Pixel 1, Pixel 2, 3, 4, 5, and blah, 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 and some Samsung devices or whatsoever. So you should be fairly good. If you are serious about latency, you just get pro audio ready devices. And even if you are building some music-related applications, like I know some people are building music streaming applications or video streaming applications whatsoever, they use Jetpack Media 3, which used to be called Exoplayer. And Exoplayer is not even using this A-audio feature. It's using traditional audio track feature, and usually people don't really complain about its latency or whatsoever. It's usually not problematic. If you hear any delays, they are most likely from network or whatsoever. But when we build some creative music applications, the live interaction with the user and the device is really important, so we care about that. And the second most heard complaints is like, Android is based on Java, so I don't want to deal with Java. And I hear a lot of those from audio app developers, and it's true. I mean, it's kind of annoying, but as I said earlier, Java doesn't really matter on non-audio threads. For audio threads, we use C++ for audio code, and it doesn't really matter, or C++ or C or Rust or Zig or whatsoever, but the majority of us is like C++. And regarding GUI, Android is not the only platform that mixes more than one programming languages. Like, say, you can use, say, Dart or JavaScript or C# whatsoever for cross-platform applications, or say we can also use C++ for GUI as well, and it's actually quite popular in audio application development. Like there's a popular library called Juice, which is like, say, more than 50% of audio developers are using that. So we are a very special kind of world. And other people are using OpenGL or Vulkan or whatsoever, or Qt or whatsoever. So it's not very special. Android is not very special around here, actually. And if you're curious about how we write audio code in Android, there are a couple of technical sessions from Android audio team. They gave some session talks at some audio conference in London called ADC, and they were fairly good ones. And one of my favorite titles is Winning on Android. And today my talk is rather about winning on Android is not enough because Android itself is not winning. So we need to get Android itself as a winning party. So number 3 is iOS provides more features, but Android doesn't. It's very commonly hard ones. But Android actually provides a lot of features, especially recently. For example, Android comes with MIDI API, not just MIDI version 1, but also MIDI version 2, both in Java and C++. A funny story around here is that Android is actually ahead of other platforms. So when Android implemented MIDI version 2, there was no corresponding support in the underlying Linux also. So they had to implement MIDI feature in Java somehow. It's kind of funny. And we also have spatializer support and hardware accelerated head tracker stuff for Android XR. So we are not behind there, starting Android 12. And they have been working on LE audio support and some codec enhancements whatsoever for Pixel buds. So Bluetooth is also supported fairly well. And they also even support audio plugin services for Android Auto, starting Android 14. So they are not really behind. So can you name any missing feature in Android? Well, actually, yes. I'm pointing one. We are missing audio plugin features. Audio plugins are the frameworks or libraries for building instruments and effectors. And it's not only for music software. We also use these features on other softwares as well. And the Apple platform has a feature called Audio Unit version 3, which is used widely for DAW and instruments whatsoever. So these ones with green lines are missing on Android, and that impacts a lot in the market. And the last item I mentioned is mobile platforms are in general hard to deal with, and it's very true. Like we have limited computing resources, like we have much less memory or much less storage space or whatsoever. And we also have smaller screen on mobiles, and it's way smaller than desktop. And we can use one application per screen at a time in general. And the application ecosystem is like isolated. They are totally isolated, so they can't work together, kind of. So we cannot really fix this kind of issues. So what we should do there is like we should have totally different objectives and product goals for mobile version of the music software's products. And of course, it's not only about Android. iOS is hard too. So audio developers actually don't really like to work on mobile products in general, even on iOS anyway. But iOS is still running ahead of us, so we should catch up. And by the way, there's new desktop mode support on Android tablets these days, so things might be changing in that surface, but that's another story. It's a kind of futuristic. And I didn't really explain what audio plugins are. So when we try to compose music, we use softwares called DAW, Digital Audio Workstation. I'm explaining this kind of basic stuff because, you are Android developers, not audio developers. When I talk to audio developers, I totally skip this kind of section, but I need to explain this kind of stuff here. So we use DAW for composing music. And it's, take it like, say, it's more like an IDE for music composers. Like when we build some software, we use IDE to write code and build and run. For musicians, they use DAW to write songs and listen to it, or even, I would say, debug their music. Like, oh, this part is wrong, whatsoever. So it is similar. And audio plugins is an instrument, something like synthesizers or effectors. There are many different instrument vendors, like real instruments vendors. Like, say, if you think of piano, there are companies like Kawai, Yamaha, Korg, Roland, whatsoever. And if you think of guitars, there are companies like, say, Gibson or Ibanez or whatsoever. So they are kind of artistic work. They are more like programming libraries for programming language runtimes. And lastly, I would explain there is things called audio plugin formats. Formats are APIs to play some instruments. Like every instrument needs to receive some instructions to play them. So we need some API. So it used to be MIDI version 1, which is used to play those instruments, but MIDI version 1 is not expressive enough. So music composers kind of switched from MIDI to audio plugins. So they, instead of letting the MIDI devices, we use MIDI audio plugin software to receive the precise audio outputs. And there are some audio plugin, common audio plugin formats such as VST3, Audio Unit, LV2 Clap, X on desktop. And while they are totally different APIs, the actual purpose of the audio plugins are quite similar. Like, say, basically it receives audio inputs and something like MIDI inputs, event inputs, and then generate some audio outputs. Like, think about some effectors. Like, it receives some inputs and give some make some changes and get some audio outputs. So this is a principle. So audio plugin formats are like programming language runtimes, I have to say. iOS has Audio Unit version 3, so any kind of DAWs on iOS can conform to this Audio Unit format, and then it can make use of any instrument software that also conforms to Audio Unit format. So it's kind of around any arbitrary combinations. Also, think about something like, say, language server protocol and VS Code. Thanks to those specifications, any kind of languages can be used on one single editor, and it's not limited to VS Code. Any editor that supports language server protocol can benefit from that. Android is missing this functionality. So this impacts a lot. So it is still possible to build DAWs on Android, but it's more like, say, one single DAW contains every instrument that the DAW supports. Anything outside that is not supported. So that's kind of a sad state. It's not very global and ubiquitous. And it should change. And there are some, for example, there are some existing DAW on Google Play already. And this is an example I'm taking from some review on Google Play Store. Cubase is a very popular DAW from a company called Steinberg, which produces a very famous DAW called Cubase. This port is actually quite great, but the review is not that great because their users are complaining like we cannot really use any instruments like Audio Unit like on iOS. And Steinberg actually responds to it like we cannot really do that because Android misses this feature. So This is a platform problem. There are also some other people saying that audio latency like, is not really a problem on Android anymore, but we are still missing audio plugins on Android. That's a problem. And it's like from 2023, fairly recent. So it's a current problem. So can't we actually build audio plugin systems on Android? Can't Google do that? Actually, it's kind of possible. Like, actually, I'm building some experimental audio plugin formats by myself, and it actually told me a lot. There's a lot of technical hurdles. So let me explain where we will be stuck. So take my example. Take my experiment like existing iOS audio bus project, which was not from Apple. There were some community developers on iOS community who tried to build something similar. So I'm doing something similar. Let's understand how audio host DAWs and plugins work on desktop. In general, on desktop platforms, those DAWs can load audio plugins as a library. So on desktop, those audio plugins are built as a program, DLL or DLive or SO. So we can use DLOpen or load library on Windows. But on mobiles, we cannot really do that. Like, you can't really take some random dynamic library from another application to load in your application. That's either technically impossible, or actually it's possible on Android, but it's prohibited. So if you do that, it's prohibited on Google Play Store. So if you do that, you will be kicked out from Play Store. I have some kind of funny story. When I visited Linux Audio Conference back in June this year, there was a conference called Linux Audio Conference, and they are all Linux developer and audio developers, so they are small pie, but there were like 30 to 50-ish people over there and discussing those kind of stuff. And there were a handful of Android sessions actually, so they were actually using Android, but the way how they used Android was like they first get rooted and then they can access arbitrary features on the Android audio features. So it was kind of totally different. I'm explaining something on top of the standard Android platform features. So on standard Android platforms, we will have to use IPC, inter-process communications between the host application and the plugin applications. And Android is fairly good in this region. Android system had a fairly solid IPC foundation called Android Binder, which even supports real-time priority inheritance starting Android 8. Real-time priority inheritance is like, say, if you have some audio thread application on DAW, and if you switch to IPC, if this application doesn't have real-time thread priority, it needs to be elevated to real-time priority as well, because otherwise the real-time thread will have to wait non-real-time application plugin thread, and it's called priority inversion problem that is commonly used. It's a common term in real-time programming world. So we can avoid thanks to this real-time priority inheritance feature. But the thing is that this feature is only available on the platform developers and vendor developers, so it's not available to we app developers yet. I really want this feature, but it's difficult to happen. Another obvious problem on Android is that you cannot really show external another application UI on top of your UI. So there's a DAW application and there's a plugin application which were built by other people. But I somehow made it. This screenshot shows the left side is a screenshot from native DAW application, I mean the native GUI application, and which loads plugin UI, which was written in Jetpack Compose somehow. And the right side is the flip side. The host application, some kind of experimental testing hosting stuff, is written in Jetpack Compose, and I'm hosting some plugin native GUI from plugin UI from some native application. Why is it possible? There's some solution starting Android 11. They have a feature called Surface Control View Host, which helps you, makes it possible to render any view from another application on our host surface view. So if you, since this is instantiated by the host itself, it's not like there's a security problem like hijacking UI or whatever. It doesn't matter as long as you use Surface Control View Host. But it's also very hard to deal with. Like I can't really debug the plugin UI on the host application, and I still have a lot of problem over there. There are a couple of other solutions like using Web UI or System Alert window, but I don't think I have enough time for that, so let me skip that. So how about Audio Unit version 3? Why only Android is stuck at this? And how did Apple achieve these features? Apple actually had Audio Unit version 2 on macOS earlier than iOS, and they only had to make some changes to get it working on iOS as version 3. Well, I'm saying it's slightly minor work, but it's actually a lot of work. But it's still easier than building from scratch. The way how Apple achieved Audio Unit version 3 is like they make use of the platform feature called App Extensions. App Extension is a generic feature that any application can load external features through extensions. Like extensions are like, say, you're maybe familiar with Chrome extension or Firefox extensions or VS Code extensions, Android Studio extensions, plugins, whatsoever. They are similar. So Apple made it like the DAWs could load audio plugins just like an extension. And they even released a product called Logic Pro for iPad. Logic Pro is a DAW from Apple. And it makes full use of this audio unit feature. And of course, it's not only limited to Logic Pro itself. Any DAW, like say Cubassist from Steinberg, can also benefit from this feature. And they also made some improvements over mobile. Audio unit on mobile friendliness. Like their GUI can be shown as very small, tiny UI, like tiles, like on these screenshots. It is actually taken from the Logic Pro website, and they shows like only 1, 2, 3 knobs to control on this small screen. And of course, they can provide full screen, bigger UI to control more stuff. But this compact view is a very nice feature to have. And iOS also achieved the real-time priority inheritance feature that I explained earlier to even user space called XNU turnstiles or audio work groups. They are nice features to make other real-time threads working together within a DAW. So they don't really have any concern around real-time priority inheritance and real-time processing. So this is really nice. And Android is missing that. So I would say we should make changes in Android ecosystem, but there are two folds. Android platform should change something, and we, app ecosystem developers, needs to make some move. The first platform, it seems like I would say if you open up the real-time priority inheritance to everyone, we would be then able to make audio plugin framework by ourselves, that would be easier. But I don't think it's going to happen, because if you give any real-time priority inheritance to random developers, maybe they would just abuse it, and everyone try to get the highest priority, and the ecosystem is like doomed. So I don't think it's going to happen. But Android 16 supports very interesting feature in this regard. Like, starting Android 16, the vendors can provide some media codecs implementation that can be loaded in process within the user's application. That means, like, without that feature, we always had to process. Those vendors had to provide media codecs out of the process within the containerized process space, and they had to resort to IPC. They under the platform needed to resort to IPC. But if you are using in-process media codecs, it doesn't happen, and it gives better performance, or the priority inheritance doesn't matter there anymore. It's very good, but it comes with a somewhat interesting limitation. Like, the code itself must be written in safe language. And Google doesn't really explain what is a safe language, but people assume that it must be Rust. Rust is apparently a safe programming language. And the way how this safety is verified is, like, they use some Apex package to distribute those codecs, and the platform examines those native library contents within the Apex. Apex is like APK, but provided by vendors usually. And the platform can inspect the native libraries within it, and then verify it if it's safe. So it's a very interesting feature. Can we do something like that on a plugin system? Technically, maybe it's possible, but it's actually it brings in other difficulties. Like, say, now that we have different processes, DSP real-time processors in the user app process, and non-real-time processors that works like, say, loading some file streams on like web data to give to audio thread, is residing in another plugins app process, and now they need to use IPC, and it's going to be kind of difficult. The difficulty is put over app developers, and it's not. I don't think it's going to happen. Another easier solution would be just give some IPC priority inheritance to some verified application code. And maybe that's easier, but right now there's no official way to build a safe code for Android developers. Like, even Rust is not even provided by NDK team. It's not official language. And even if we can use Rust, I don't think that's going to happen, because those audio plugin developers are more like artists. They make their best effort to create great sound, and they are right now using C++ anyway. So the solution I can still think of is more like, say, we can migrate to safe C++ kind of stuff, but it's just an idea, and nothing happens. There's even no open source safe C++ compiler right now, so I'm not sure it's going to happen. But Google has some language called Carbon, so it might be not very dreamy. It's kind of realistic. But let's think about that as a future. Community people can do something to get the situation better. We can build some inter-app audio ecosystem, like, say, I'm building some audio plugin format by myself. If something like that happens, Google can think of how the actual use of those. And we can also improve some Android supporting cross-platform musical C++ audio app libraries whatsoever, because most of those existing app developers are using those cross-platform technologies. Like they have to support cross-platform and also multi-plugin formats, and so they usually don't want to deal with respective plugin formats and platform code, and instead they just write one single code to build everything for many platforms and many plugin formats. Actually, I actually ported those cross-platform code, plugin code to Android, and so I don't really have time to show you, but I have a lot of audio plugin software within my device. So if you are interested in this kind of stuff, let me talk to me, and I can show you some later. And we can also support and enhance cross-platform technologies in general for easier porting from desktop. Like by using MIDI version 2 feature, which actually has a lot of overlapped feature with audio plugin API. So instead of using audio plugin API, we can kind of use MIDI version 2 features. For example, that's another experiment that I have right now on my at hand, but I'm not going to talk much about that. And we can also make full use of Web UI stuff, which is also getting popular on audio app developers. And we can also use JavaScript and WebAssembly whatsoever to make things happen. So I don't think I have a lot of time to wrap up, but it's a quick summary. Android platform achieved a lot of audio features, and except for audio plugin features, and that's why we are behind iOS. So we should make some changes to make it happen. So we can kind of build audio plugin ecosystems without real-time concern, and it's an ongoing concern, and we have to fix that. I mean, Google should fix that. And we can still, on the other hand, we can still improve the ecosystem by ourselves. That's what I wanted to talk about today. And thank you so much for listening to them. And I have some links to those. I have linked to my project and some existing speaker deck slides. I mean, I gave a lot of similar talk in the past in a couple of conferences like this. So if you are curious about them, have a look at it. And if you have any questions or whatsoever, I have some social accounts on Mastodon or Blue Sky. I quit Twitter, so I'm not reachable there. So if you want to talk to me, either do it right now or find those ones. And if you're curious about the audio community in the world, there's under the Audio Dev Discord. So I'm just like one of few people who actually talk there. And there's not a lot of people there, but if you are interested in Android and audio, you are very much welcomed there. All right, thank you so much. Okay.